Ladies and gentlemen, this is Miss Humbert here. So today we're going to be doing just a little bit of a probability review. Now, probability is something that you experimented a little bit with in middle school, most likely. And so we're going to just kind of start taking it a step further. So I kind of want to review some of the things that you guys talked about in probability in years past. So first, taking a look at calculating out probabilities. And so this is actually your big box on your sheet. I know two of them say calculating probabilities. This top one is your big box. That is a measure or estimation of how likely it is that something will happen. So that's what the probability is. How likely is it to happen? Probabilities are a value between 0 and 1. 0% chance meaning no way that's going to happen, and 100% chance meaning it's guaranteed or will happen. And it's actually snowing right now, which is kind of sad. So 100% chance that it's snowing. The higher degree of the probability, the more likely the event is to happen. So if a forecaster said there's an 80% chance of snow, it's probably going to snow. The notion P of A means the probability of A. So when we're talking about calculating out probabilities, we want to take our number of successes and divide it by the total possible outcomes. So on the top, it's success. On the bottom, it's total. So let's take a look at the probability of rolling a 1. So if we're thinking about a dice, so I have a dice up here. So if we're thinking about these dice up here, they have 6 sides to them. Okay, so that's the total number for all of these. The total number possible of outcomes is 6. Then the probability of rolling a 1. Well, how many times does a 1 show up on there? Just once. So the probability of rolling a 1 is 1 out of 6, which is 0.167. So there's about a 16.7% chance that that's going to happen. Now when I do probability, I like to round to 3 decimal points so I can keep it just a little bit more accurate. Next, I want to calculate out the probability of rolling a 2 or a 3. Well, there's 1 2 on a dice and there's 1 3 on a dice. So that means there's 2 successes if we roll a 2 or if we roll a 3. So that probability is our number of successes over total possible outcomes. And 2 divided by 6 is going to give me 0.333. For the next one, we want to look at the probability of rolling an even number. So what even numbers are on a dice? You could get a 2, you could get a 4, or you could get a 6. So 2, 4, and 6 are all considered successes. So what are we going to do? Well, we're going to have 3 successes out of 6 total. So that's going to be 3 divided by 6. And when you calculate that out, you end up getting 0.5 as your decimal. I could add zeros after it if I wanted to have 3 decimal points, but really 0.5 is what we need. For the next one, rolling a number more than 2. Well, we need to figure out how many numbers are more than 2. 3 is more than 2. 4 is more than 2, 5 is more than 2, and 6 is more than 2. So 1, 2, 3, 4. So there's 4 numbers that are greater than that 2. So that means that 4 out of the 6 are going to be our success. So when you divide 4 divided by 6, you get 0.667. So please be really, really careful on your rounding. If you were to type this in your calculator, which you should always be doing along with me, 4 divided by 6, you get 0.6666666, and you just get a whole lot of 6s. So you want to make sure you round that to the nearest decimal point, which is 7. Or when you round up that last one, which is 7. So the probability of rolling a prime number. Now remember, a prime number is a number that can only be divided by 1 and itself. So 1 is not a prime number. 1 is not a prime number. So the prime numbers on the dice are 2. 2 is the only even number that is also prime because it fits that category of only being able to be divided by 1 in itself. So 2 is a prime number. 3 is a prime number, and 5 is a prime number. So each of those are prime numbers. So there's 3 successes out of the total possible outcomes. So 3 divided by 6 is going to be our probability. When you take 3 and you divide it by 6, you end up getting 0.5. So what that means is there's a 50% chance that you roll a prime number when you roll a dice. Now, I found that students don't play cards as much as I would like. And so cards are just kind of fun, and we actually use them a lot for probability. So on the back side of your note sheet, you're going to kind of write down some deck of cards in a nutshell. So instead of running up to me every single time you don't know how many of this cards or how many of this cards are in a suit, please go ahead and just reference this note sheet. That's kind of why we're doing it. So cards have 4 suits: clubs, diamonds, hearts, and spades. Each of those suits have 13 cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Queen. Some people count ace as a numbered card because it technically represents 1, but most of the time it's not counted as a number card. So notice that ace has 4 of each type. 2 has 4 of each type. Okay, so that kind of gives you an idea of some of the probability that we're going to be doing. So let's just take a look, and if you go and you flip onto the back side, you can fill out these numbers. So there's 52 cards in a deck. There's 13 cards per suit. There's 4 cards per number. There's also 12 face cards. So that these right here represent your face cards. There's also 36 numbered cards is what you talk about because there's 9 numbered cards per suit and then there's 4 suits. So that's how you get the 36 numbered cards. And as far as red and black cards go, there's 26 of each, okay? Because if you notice, there's only red or black. So half of the deck is black and half of the deck is red. So that's how you can kind of lay out those cards. Again, this will help you as you're trying to do some of these problems. So I do suggest having that note sheet available to yourself. So that just kind of fills out that chart for you in case you didn't get it as I was talking about it. So if you didn't get it, go ahead, pause the video, and make sure you get all of that written down. Next, let's take a look at this one. So we want to find the probability of getting a spade. Well, first of all, for all of these, all of our possible outcomes are 52. Okay? Then we want to figure out the number of successes for each of these. So we want to figure out the probability of getting a spade. So what is the probability of getting a spade? Well, a spade is one of our suits. And then I noticed that per each suit, there are 13 cards. So the probability of getting a spade is 13 out of 52. So you take 13 and you divide it by 52 and you get 0.25. So there's a 25% chance of getting a spade. Well, that would make sense because there's 4 suits and one of the 4 is spades. Now let's take a look at an ace. So an ace is a type of card. So for each type of card, there's 4 cards for each number. So there's 4 successes. So then we're going to take and we're going to do 4 out of 52. So then in your calculator, you can do 4 divided by 52. Go ahead and type that in so you can make sure you know how to round correctly. Because when you round it correctly, you should get 0.08. So that means that there's only an 8% chance of you drawing an ace every time you draw a card. Let's take a look at this next one. Probability of getting a red card. So we talked about the red card being half the deck. So there's 26 that are red. Well, since it's half the deck, I bet our probability is going to be 0.5. Just saying. So we're going to take our number of successes divided by our total number of cards. So 26 divided by 52. When we do that, we end up getting 0.5. So there is a 50% chance, just like I estimated, that 5 did not work. There's a 0.5, so there's a 50% chance of that occurring. Next, getting the Jack of Clubs. So the Jack of Clubs is actually a specific card. So since it's a specific card, there's only 1 out of the 52. So then you're going to take and you're going to do 1 divided by 52, and that gives you 0.019. So that is a really, really small number. It's not very likely that you're going to get that card at all. There's only about a 2% chance of that actually happening. So yeah, not so likely. All right, next, let's take a look at a probability of getting a face card. Well, I see in my chart above that there are 12 face cards in my deck. So my number of successes is 12. My number of possible outcomes is 52. So then I have 12 divided by 52, and that's going to give me 0.231 when I divide it out. Again, I strongly encourage you to be calculating these along with me so that you know you're doing it correctly. So there's about a 23.1% chance that you'll draw out a face card. Next, let's take a look at some just general probabilities. You have a bag with with 3 red marbles, 2 green marbles, and 5 blue marbles. So first thing I want to do is figure out my total. So I have 3 plus 2 plus 5. So that's going to be 10 when you add all of those together. What is the probability of grabbing a blue marble? So now blue marbles represent my success. So I see that there are 5 blue marbles. So my success for grabbing a blue marble is 5 divided by 10. And when I do 5 divided by 10, I end up getting 0.5, which means there's a 50% chance that I grab a blue marker out of that bin. Next, let's take a look at number 2. You decide you want to read Harry Potter. You go to your bookshelf and randomly pick one of them. What is the probability you do not choose the first book in the series? Well, first of all, you have to know a little bit about Harry Potter, and there are 7 books in that series. And we want to find the probability that we do not choose the first book in the series. That doesn't mean our success is 1 out of 2, because we do not want to choose the first book in the series. That means that there are 6 other books that are not the first book in the series. So that means 6 out of the 7. So 6 divided by 7 is 0.857. So there's about an 85.7% chance that you get one that's not the first book if you're randomly to select it. Next, let's take a look at number 3. You need to make a doctor's appointment next week. What is the probability that it is on a weekday? So let's think about the total number of days. So there's 7 days in a week. Now we need to think about, okay, how many of those are weekdays? Well, Monday, Tuesday, Wednesday, Thursday, Friday. So there's 5 days that are weekdays. So our success is 5. So then we're going to do 5 divided by 7. And that gives you 0.714. So that means there's a 71.4% chance that your doctor's appointment is going to end up during the week if we have all of those days open to us. Last but not least, let's take a look at number 5. There are 4 male and 6 female puppies at a breeder. What is the probability that you get a female puppy? So what we want to do is first calculate out our total. If we have 4 males and 6 female, that means we have 10 total puppies. Our success is the number that is female, so that's 6. So 6 out of our 10, which gives us 0.6. So there's a 60% chance of us drawing a female. So what I want you guys to do is go ahead and get that Schoology quiz taken, and that concludes your note video. Thanks for listening.